Hi guys, you welcome back to my channel. Back to the promised video. Now, in today's lesson, we want to take a look at the Iupac nomenclature of alkanoic. In our previous video, I explained extensively the definition of alkanoic. Then we take a look at the naming of alkanoic from ethanoic acid down to octanoic, nonanoic, and decanoic acid. In the previous video, I made mention of something that when we are talking about this alkanoic or the carboxylic acid, the OIC, which is oic, is being replaced in place of you removing the E in alkane with oic. So guys, the first thing you need to understand as far as carboxylic acid or alkanoic acid is concerned is that let's take a look at the Iupac nomenclature, which is the same thing as the rules that governs the alkanoic acid or the carboxylic acid. Come closer. So guys, the first thing is names end in oic, that is we are going to what? Drop the E in alkane and replace with suffix oic. That is the meaning of that. The second one is that we have to consider the longest continuous chain chosen should contain the functional group. This is a carboxylic functional group. That is, if you have to name any compound as far as the carboxylic acid or the alkanoic acid is concerned, you need to consider the continuous carbon chain from where you have the functional group. Is that clear? And the last one is when their subsequent numbering starts with the carbon atom of the functional group. That is, if you are given any functional group, if you are given any compound that you have to name as far as the carboxylic acid is concerned, you need to consider the numbering irrespective of where the substituent is placed. You need to consider the numbering from where you have the functional group. Is that clear now? So guys, let's take a look at some examples under the carboxylic acid and how we can easily apply the Iupac rule to it. Come closer. The first compound we take a look at is the first one, CH3, CH2, CH2, COOH. We have A, B, I have CH3, CHOOH, CH3, CH2, CH3. So now, guys, before we continue, let's take a look at these two compounds before we add M to the whiteboard. So guys, looking at what you have on the board, according to the rules, we have to start the numbering from where we have the functional group. So guys, I have 1, I have 2, I have 3, I have 4. 4 under alkane is butane. But for the fact that we have dropped this E and replaced it with what? Oic. That will give us what? Butanoic. So yeah, for the fact that we have 4 carbon atoms according to the naming of the carboxylic acid, here is called the butanoic acid. Butanoic acid. Is that clear now? Come closer. Let's take a look at this. Some students might feel like, how do we have this substituent being attached to this now? Are you with me? So guys, for this, I can easily say, here is where we have the functional group. How do we name it? Irrespective of where the functional group is placed to, you start the numbering from that functional group. Is that clear now? So guys, I can say that I have 1 here, 2. So the longest chain is this, not this place. We have 3. We have what? 4. So guys, now looking at what you have on the board there. For this, we can easily say that 1 for the functional group, 2 for this carbon atom here, 3, 4. Now, these 2 here, we have this arrow here. We also have this what? This arrow here. The longest carbon continuous chain here is 4, which is the same thing as what? Butanoic. Are you with me now? So guys, this 2 here is going to affect the CH3 here, also affect the CH3 here. With that, the CH3 there is what? Methyl. The CH3 here is what? Is what? Methyl. For the fact that the carbon atoms here contain 2 methyl, so that will give us 2 dimethyl butanoic acid, since we are having 4 as the longest carbon continuous chain. So let's take a look at other examples as far as the carboxylic is concerned. So example 3, I have CH3, CH2, C, OH, I have CH3 here, I have CH2, I have CH2, I have CH3. The next one, we have CH3, CH2, C, we have H here, CH2, I have CH2. So guys, for this is another compound. And mind you, for what we have here, we can take a look at this in this form as well. But for this C, this is a C, Y here is for what? D. For this C, now, let's take a look at it now. This is where we have our functional group. Many students out there will make a mistake of starting the numbering from this side. The naming of this alkanoic acid is different from the way we name our alkanol. But from that alkanol, we always consider the numbering from where we have the functional group. The same thing is applicable to this. But some students will make a mistake of saying we have the numbering, we have 1, 2, 3. No, it is wrong. But the numbering will either or rather start with this functional group here. 1, I have 2. The longest chain, if I said 2, 3, 4, no, it's wrong. So let's count like this: 1, 2, 3, 4, 5. Now, I'll be using this small arrow here to indicate the substituent attached. This substituent attached here is just 2, this and this. And mind you, among the rules is that when you are naming any organic compound, you need to consider alphabetically. Don't make that mistake of putting methyl before a T. So guys, what we have here is a T, and what we have here is methyl. So guys, the number here is 2 ethyl, 2 methyl. Guys, how many carbon atoms for the longest carbon continuous chain is 5? That is pent. So we have it to be what? Pentanoic acid. So pentanoic acid. Is that clear now? So let's take a look at this D. Mind you, when I was naming this compound here, we did not open the functional group like this. So guys, how can we name this kind of a compound? Don't forget, you have to consider the numbering from where you have the functional group. With that, you can easily deduce the naming easily without stress. Are you with me now? So guys, I have 1 here, I have 2, I have 3, I have 4, I have 5, I have 6. You need to understand one thing about organic chemistry. The concept is that anything you think of, the naming you think of for a compound given to you or the compound you come across, among all the options given to you, if you think of anything, if care is not taken, among those options, that thing is there. But you need to understand the concept of how you can easily apply the rules to it. Are you with me? So guys, come closer. For this, we're having 6 carbon continuous chain, and 6 is called hexanoic. So which is hexanoic acid. So guys, let's check where the attached substituent and the number that is placed under the attached substituent. So we have 4 here, so that will give us 4 methyl hexanoic acid. Are you with me now? So guys, I'll be naming 2 more compounds. As far as organic chemistry is concerned, chemistry core is there to tackle any question you have. So let's take a look at some other naming as well. So we're having this. Some other naming as well. This. So for this, I have CH2, CH2, COOH. Okay. Then I have this with double bond. I have CH3, I have CH. So guys, looking at what you have on the board, for the fact that we are having 2 carboxylic there, sorry, 2 functional group of the carboxylic acid there, these are going to name this kind of a compound. Always just consider the carbon atoms you have there. Let's see, we have 1, 2, 3, 4. 4 is what? Boots. Now, the functional group is what? 2. Just the way we always name each compound by giving them identical. Now, we are going to give this compound an identical. So, this will give us, for the fact that I have 4 carbon as boots, Abby, so that will give us butanedioic acid. Butanedioic acid. Why do we call it butan? I don't want to call it butanedioic. So you can say butanedioic acid, or you call it butanedioic acid. For that di is identical. Oic shows that it is a compound of the what? The carboxylic acid, the family of the carboxylic. So guys, for this one, now we are having a double bond here, and we are having a carboxylic acid here. It is in the same method. You start the numbering from the functional group. I have 1, I have 2, I have 3, I have 4. So now it is now butanoic. It is now, initially you can call it butanoic, but yeah, it is butanoic acid because of the alkane that is being introduced, which is what? The double bond. Are you with me? So you can say here we have buts to anoic acid. Is that clear now? So this is a beauty behind how we can easily name carboxylic acid or the alkanoic acid. So let's take a look at 2 more examples. So guys, the next examples we'll be looking at here is, let's take a look at this example here. I have CH3, I have CH3, I have CH2, I have CH, then here, bromo, I have CH, I have this, then I have this. So guys, if you have to name this kind of a compound easily, don't forget that you have to start the numbering from where you have the functional group. So guys, I have 1, I have 2, I have 3, I have 4, I have 5, and I have 6. The 6 is hexanoic acid initially, right? So guys, if you have to name this compound, don't forget that if you have to name this compound, you have to consider the substituent attached to it. Are you with me now? The substituent attached to it, mind you, the 4 here is for what? Bromo. The 3 here is for what? Methyl. And the rules is that we have to name it alphabetically. So guys, you can say we have 4 bromo, we have 3 methyl hexanoic acid. Are you with me? Again, 1, 2, 3. This is what? 3 methyl, and here we have what? The 4 bromo. So guys, initially when it comes to this organic chemistry naming, as far as this carboxylic acid is concerned, you need to consider the numbering first at where you have the functional group. Exactly. So guys, if you have any question, do well to drop it in the comment box. In our next video, we'll take a look at the physical and the chemical properties of carboxylic acid. So guys, don't forget to subscribe to my channel, like, share, and if you are a student who is preparing for the forthcoming WAEC, JAMB, and NECO examination, this video is for you.